a fait le tour de France et le tour de la...
We went around France and around the Iberian Peninsula, and on the way we went past some very windy areas with strong currents.
On a vraiment besoin de beaucoup d'énergie.
At those points you really need a lot of energy. You can navigate with solar energy on low power, but as soon as conditions become difficult, you start the fuel cell and you get the power that you need. The mistake would be to rely just on batteries to store hydrogen. And sure, their output is superior, but to make batteries you need lithium and cobalt, and those resources aren't infinite. People talk about distributed energy, digitalization and decarbonisation. The Energy Observer is an example of the future of energy networks.
Un exemple du futur des réseaux énergétiques.
Hello and welcome to this special edition of Tech 24. We're aboard Energy Observer. This X-racing catamaran, powered by hydrogen, is on a 6-year voyage around the world and is currently sailing along the French Riviera. It's a great opportunity for us to ask this question. Is the most common molecule in our universe, hydrogen, set to become the fuel of the future, powering our cars, our homes and offices? Let's first find out how hydrogen is produced.
Hydrogen is one of the most abundant elements on the planet, but it does not exist in the natural world on its own. It is often associated with other elements. Take water, for instance, which is composed of 1 oxygen and 2 hydrogen atoms. But in order to use hydrogen as an energy source, it must be separated from the compounds that contain it. There are 3 ways to isolate hydrogen. Steam reforming, the most common method, involves extracting hydrogen from methane. But the process produces carbon dioxide, a greenhouse gas. Coal gasification involves the heating of coal at high temperatures to form a gas. But this method releases carbon monoxide, another dangerous compound. The last method, electrolysis, uses electricity to split the water molecule, or to separate the hydrogen from the oxygen. Though it is the cleanest way to obtain hydrogen, it is costly. Electrolysis is 4 times more expensive than steam reforming. As a consequence, 95% of the hydrogen produced in France still stems from fossil fuels.
And in Israel, an experimental method aims to create hydrogen that won't be that expensive to produce because it will be grown. No need for batteries or any apparent technology, harnessing nature in its most basic form, algae, after tweaking each cell first. Iris Mackler reports.
One of the most basic life forms is a single-cell algae growing near water. Who'd have thought it could produce enough hydrogen to power anything, let alone an electric vehicle? This grow-your-own hydrogen is the dream of Tel Aviv University scientist Dr. Yiftach Yacobi.
We think about using algae as biofactories. You have a factory that builds itself, multiplies itself. You don't need to, you can take it back to Britain, to France, to anywhere on the planet and make it into 20,000 liters.
Algae produce a small amount of hydrogen each morning. Dr. Yacobi's innovation has been to tweak the algae gene to see if he can speed up its hydrogen enzymes. Some of the new algae clones are producing more hydrogen.
So what we have here is a clone that produces hydrogen for over a week in a continuous way. This is graph that go up. That means increase percentage of hydrogen. What happens here, honestly, we have no idea how that's possible.
Once they figure out how it works, they plan to farm this revolutionary algae clone. The idea is to find empty land, say in the desert, where they can grow algae using only salty or wastewater, and to produce enough hydrogen to power every car in Israel for a year.
For 3 million cars, you need a land area of 145 square kilometers. It's less than 1% of the land area of the state of Israel. It's very little, but that's the goal.
Their other goal is to produce their hydrogen for under €4 a kilo, less than what it currently costs to fill a tank with gas. And they hope to make this dream a reality within the next 10 to 15 years.
We've just seen how hydrogen is produced, but another issue is how to transport and store this bulky gas. One way is to compress it, but that requires energy and it raises safety concerns. Today, new and innovative solutions are emerging, and one of them is from the French startup Hyci Labs. Well, I'm now joined by its founder and CEO, Pierre-Emmanuel Casanova. Thank you so much for joining us here on Tech 24. So you've created a technique that facilitates the storage and transportation of hydrogen. Tell us more about how it works and why it's so groundbreaking.
So basically at Hyci Labs we created a liquid carrier, a liquid hydrogen carrier. It facilitates the deployment of hydrogen because it's a liquid that is not considered as a dangerous good. So it's easy to deliver, and then when we will need it to extract the hydrogen from the carrier, there is no energy input. So it is the same, we will have the same benefit as hydrogen with the benefits of a liquid solution.
So is this solution 100% green, and is it safe?
So basically there is two technologies. The technology that we charge the liquid carrier, and when we charge the liquid carrier, all the process is 100% environmental friendly. Then it's just transportations, and then when we need to extract the hydrogen, it's also just no energy input, so environmental friendly. But of course, we just transport hydrogen, so we need that the hydrogen at the beginning has to be green.
So for now, your solution is used for a wide range of purposes, but not yet for green mobility. Is that the ultimate goal?
It is the ultimate goal. Of course, our solution is well adapted to this kind of solutions. Of course, we need to work with big players and industrial players in the field of hydrogen to push our technology and facilitate the deployment of green solutions like hydrogen.
Pierre-Emmanuel Casanova, thank you so much for speaking to us here on Tech 24. Hydrogen's greatest promise is that it will one day power our electric cars, and it's already a reality. It happens thanks to a fuel cell, which takes advantage of the fact that if you react hydrogen and oxygen, energy is released. It's essentially the reverse process of electrolysis. On one side, hydrogen molecules, on the other, oxygen contained in the air. A chemical reaction occurs between two electrodes, which in turn creates electricity, and the output is only water. Leading the way of this green revolution is the Japanese car maker Toyota with its Mirai fuel cell car. Our in-house expert Dan and Jay Cattlecar is in the French capital to test drive it for you. Dan, it's all yours.
Thank you, Julia. It took Toyota more than 20 years and 5,000 patents to develop the Mirai, which is one of the world's first commercially available hydrogen cars. It uses a fuel stack exchange whose mechanism we saw earlier. So in a sense, it extracts hydrogen from the two fuel tanks whose capacity is 5 kilograms and oxygen from air as it gets driven. To talk more about this, I'm now joined by Sébastien Grelier, who's the Director of Communications at Toyota France. Thank you very much, Sébastien.
Hi Dan, it's a pleasure for me.
What are the advantages of a hydrogen car compared to, say, normal petrol or diesel cars or even electric cars?
Basically, that we have the same advantage as a purely electric car, no sound, zero emission. But on top, you've got two main advantages. You've got 500 kilometers as mileage, and it needs only 3 to 5 minutes to refuel the tank to get the 5 kilograms.
Right, and perhaps one of the biggest disadvantages is its price. It costs more than 70,000 euros, is that right?
Yeah, that's right today, of course, because hydrogen technology and fuel cells cars are the first on the market. With the second generation, by the beginning of 2020s, Toyota aims to come with a half-price fuel cell car by this time.
The interiors are very comfortable, and just like an electric car, you don't hear anything inside. There's no sound of the electric motor, so that's an added benefit. One of the most interesting things on this dashboard is a button called H2O, which is to my left. Because it's a hydrogen car, the byproduct is pure water, and after every drive, you're supposed to release that water. So after you press this button, the water gets released, and it's approximately 7 liters per every 100 kilometer. This nozzle is equipped with two sensors, an infrared sensor and a magnetic sensor that ensures that it gets perfectly locked with the receptacle. We are at the first and the only hydrogen refilling station in Paris. Of course, there is one in Orly, which is about 20 kilometers from here. Now, this station particularly provides hydrogen to a fleet of 50 taxis which operate in Paris. These are operated by the startup Hype. I am now joined by Erwin Penfornis, who is the Director of Hydrogen Market at Air Liquide. Thank you for joining us.
Hello.
Why is it that there are so few stations in France?
Globally, this market is scaling up very quickly. Air Liquide has already supplied 100 stations in Japan, Germany, California. Now we're starting developing the demand at the same time with this taxi fleet. So this is the first station in Paris, soon some additional stations to come.
And what do you think is the future of hydrogen cars? Do you think more and more people will adopt it?
The Hydrogen Council has just released a report during the COP23 showing that 40% of the required CO2 emission will be ensured through hydrogen.
Thank you, Erwin. That was Erwin Penfornis of Air Liquide. Back to you, Julia.
Dan and Jay Cattlecar, thank you so much for that. That brings us to the end of this special edition of Tech 24 aboard Energy Observer. We'll keep on following the expedition of this catamaran of the future on the show. Until next time, do stay with us here on France 24.